All right. In goal 9-2, we're working with nth roots. Nth roots are cube roots, fourth roots, fifth roots, sixth roots, whatever root we're talking about. We won't go any higher than a fifth root, okay? When we simplify nth roots, we think in groups of 3, or 4, or 5. Just like in square roots, we think in groups of 2. 2 things that multiply. Cube roots are 3 things that multiply. Fourth roots, 4 things that multiply. Fifth roots, 5 things that multiply. So if you look at our little chart here, for example, if we go to where n is 3, and across the chart, n to the third power, 3 times 3 times 3 is 27. N to the fourth power, 3 to the fourth power is 81, and 3 to the fifth power, 243. In no way am I asking you to memorize this chart. In fact, get a little card out, a little piece of paper, and make a copy of that so you have that so you can use that. I'm not asking you to memorize those roots in any way, shape, or form. Okay? Pay attention to the root because that's going to make a difference how you break it up. But we're going to break it up the same way we did square roots. You're just looking for the cube root factor or the perfect fourth root or the perfect fifth root. All right, so here we go. Cube root of 125. So just looking at our chart above there, 125 is a perfect cube root. If you look down n cubed column, 125 is a perfect cube root. It is 5. 5 times 5 times 5. So if something has a perfect cube root, fourth root, fifth root, there's nothing left. If it doesn't have a perfect root, then you're going to break it up. So like the next one here, the cube root of 24. So I'm looking for a number that divides into 24 that is a perfect cube root. So I'm going to go back up to my chart here. So I'm looking down this column right here. And 8 divides into 24. So 8 is the factor I'm going to use. So I'm going to break this into the cube root of 8 times 3. And then my cube root of 8, that's a perfect number. That's 2. And then I'm left with cube root 3. So again, make a copy of that chart. Use it to help you get this. Fourth root of 81. Fourth root of 81 has a perfect fourth root. It's 3. 3 times 3 times 3 times 3. Fourth root of 32. 32 does not have a perfect fourth root, but one of the factors, 16, is a perfect fourth root. So 16 times 2 is 32. The fourth root of 16, that's a perfect fourth root. That's 2, with my fourth root 2 left. Fourth root 16 is a perfect fourth root. 2. Fifth root 64. Fifth root 64, not a perfect fifth root, but it has a factor, and that's 32. So 32 times 2. So the fifth root of 32 is 2, leaving me fifth root 2 under the radical. The fifth root of 486. So again, if you look at your little chart from above, 486 is not a perfect fifth root, but one of those numbers, 243, divides in there. So this breaks to 243 times 2. The fifth root of 243 is 3, leaving me fifth root 2. So again, let's look at that one using our chart above there. Fifth root of 46 did not have a perfect fifth root, but this was a factor. So 243 divided in there. Come over here. That is the fifth root. So that's saying 3 times 3 times 3 times 3 times 3 is 243. So that's where my 3 on the outside comes from. Cube root 40. 40 does not have a perfect cube, but it's going to break into 8 times 5. Cube root of 8 is 2. Cube root of 5, I don't know. Make sure you put your little cubes and fourths and fifth roots back on that answer. Cube root of x to the 6th. Here we go. We got some variables now. So Before, when I divided that power by 2 for a square root, you're going to divide it by 3 on a cube root. You're going to divide it by 4 on a fourth root. Divide it by 5 on a fifth root. So 3 goes into 6 evenly 2 times. Perfect cube root. 3 goes into 13 evenly 4 times with 1 left over. 3 goes into 14 evenly 4 times with 1 left over. Fourth root of x to the 24th. 4 goes into 24 evenly 6 times, none left over. Fourth root of x to the 19th. 4 goes into x to the 19th 4 times with 3 left over. So 4 goes into 19 evenly 4 times with 3 left over. Don't forget your little fourth root. 5 goes into 15 evenly 3 times. 5 goes into 17 evenly 3 times with 2 left over. So when you're working with these variables, you can simply divide it by the root. And then how many are left over? How many times does it go in evenly? How many times are left over? If you're trying to break it up, you are trying to find the perfect fifth root first, which would be something that divides by 5, and then the leftovers. So that's why sometimes it's easier in this just to divide it in your head and not write it out the long way. All right, so let's put these together. Cube root of 125. That's a perfect cube. That's equal to 5. Cube root of x to the 3. 3 goes into 3 evenly 1 time, none left over. 3 goes into 5 evenly 1 time with 2 left over. Fourth root, 162. 162, not a perfect square, or I'm sorry, fourth root. So that's going to break to 81 times 2. So the fourth root of 81, that's a perfect fourth root, that's 3. Fourth root 2, I don't know. 4 goes into 3, it doesn't go into 3. So that x to the third is just going to stay. 4 goes into 12 evenly 3 times. None left over. I think this is my last one. My last one here. Fifth root, 64. 64 does not have a fifth root, but it will break to 32 times 2. And then we'll leave our variables. So I have the fifth root of 32. That's 2. Fifth root of 2, I don't know. 5 goes into 7 1 time with 2 left over. 5 goes into 10 2 times. Sorry, I'm scrunching that in there with 1 left over. So on your variables, again, I think it's easier certainly to divide by the power how many are left over. And we could have done that in our previous lesson with our square roots as well. That might have been simpler. Like I said, I know you've touched base on this before, so if you have a way that works best for you, work that, okay? To help you the most, though, with these numbers, copy that chart that was in the notes above and have that sitting next to you when you do the OTL, and you can also use that nth root chart that's printed there in your notes on your assessments. So I don't have a problem with you using that chart to help you out. No way do I want you to memorize all those. Okay, so that concludes our 9-2 lesson for today.